Right, so we have the this thing. So you see the 0 degree London, and here you see if you go to the right side, the time increases. So if it is 12 noon here, it will be 1 p.m. It will be 2 p.m. And not just the Greenwich time is increasing. It's also the longitude is increasing. Longitude is increasing by 15 degree for every 1 hour of GMT. So until we reach, let's say, India. So India is on in the middle here, 82.5 degree east, and it is 5.5 hours ahead of Greenwich Mean Time. In a similar note, if you see the Eastern Standard Time, you will see here in 75 degree west, which is nothing but minus 75 degree, and which is minus 5 hours behind GMT. So if it is 12 noon in the London, it will be around minus 5 7 a.m. in the morning in the United States of Virginia or any other Eastern Standard timings. So let me come back to where we were. So these three are explained there. The Qibla direction is really a good feature added here, which allows you to determine where you need to pray wherever you are in the world. So for Richmond, it shows you 33 degree north of east, and it's going to be 99% accurate as far as my testing is concerned, because it uses the exact same terminology as used by the other Islamic websites in determining the same. And what you can do is you can try to confirm it using this thing and the same thing here. And so that is the whole idea behind it. So here what I have used is, I have tried to here, if you see the result from the Qibla locator, it doesn't tell you what is the basis of what is the axis from where it's measuring the angles. Maybe it's measuring, perhaps it's measuring from the north side. As far as I remember, that's the reason you see the 56 degree east of north, whereas mine would be from the east side, or sometimes maybe sometimes east of south you will see, some the north of east you will see. So mine is basically more precise, not precise in the sense, make it more user friendly, so that you understand from which axis you're going, either north or south or west, and it's going to return only acute values, not the obtuse angle. Now, and the same note regarding the Qibla locator, uh, I have a picture for that. Here is, which is also listed there. So here you can try to compare the results. Like say this is the line for Eastern Standard Time, north of east. In India, you see slightly here west. The more you go to top of the India, you see it's turning into southwest. And if you go south of India, South India, it will come out to be kind of north and northwest. So this thing has been tested, and let me return to the application again. And the sunrise time, solar noon time, and the sunset timings. So these are also going to be very accurate. I have considered the equation of time as well as the other important things which determine accurately the solar timings. Also, the difference between the GMT standard time zone and the longitude is also considered here, and the declination of the moon, sorry, solar declination also considered here. So other things are written. So these things you can also try to compare it in a website which I'm going to show you. Let's say I want to determine for the Richmond and GMT. Okay, you will need to type the GMT, so it will show you the website timeanddate.com. It's very good website, timeanddate.com. It will show you, try to go to the sun and moon. You can even show sunrise and noontime. You can show you all columns also. If you choose the sun here, it will show you the sun data. If you choose the moon, it will show you the moon data. You can choose the year as well as the month, and then try to see how the results are like this. I already tested in most of the things. The maximum error that you would find in these three timings would be one or maybe maximum two. Then the lunar date comes up here. Let's say it shows you 21st of Al Hijjah.